Welcome to this video session. I remain Samuel Chukwuemeka, aka Sam Done for Peace. In this video session, we shall solve and check higher order equations. What do I mean by higher order equations? In this context, higher order equations are equations in which the highest exponent of the variable in the equation is greater than 2. What I mean by higher order equations, these are equations in which the highest exponent of the variable, in the equation is greater than 2. You know, when the highest exponent is 1, it's linear. If it is 2, it is quadratic. Okay? You can say greater than 2 also. You can write it like this, greater than 2. Yeah, or you can say the degree. If you don't want to say highest exponent of the variable, you can say in which the degree. You can also say the degree of the variable, or degree in the equation is greater than 2. Okay, when we talk about degree, we mean highest degree as well. Okay, now you know, when it is linear, when the highest exponent of the variable is if it is 1, okay, let's say example, what type is this? If the highest exponent is 1, for instance, if you say x minus 3 equal to 5, the highest exponent of the variable, here the variable in the equation is x. The highest exponent is 1. So this is what we call a linear equation. This is a linear equation. If the highest exponent of the variable put highest exponent of variable. Okay, highest exponent of variable. Highest exponent or highest degree of variable. If the highest exponent of the variable is 2, for instance, if you have maybe 3x squared minus 4x plus 5 equal to 0, something like this, then this is a quadratic equation. The highest exponent is 2. The exponent is the highest exponent of the variable is 2. The variable is x, but the highest exponent of the variable is 2. That is why we refer to it as a quadratic equation. If the highest exponent is 3, maybe if you have x cubed minus 5x squared equal to 7. Okay? If the highest exponent is 3, then this is a cubic equation. And then if the highest exponent is 4, maybe you have 2 minus x is 5x4. This is what we call quartic equation. And the rest of them. So when we talk of higher order equations, we want to deal with equations in which the highest exponent of the variable is greater than 2. Yeah. Now, later on we shall come to complete and incomplete higher order equations. If you look at this now, this is incomplete. If you this is complete, this is incomplete, this is incomplete. What I mean by incomplete is that if you don't have all the exponents represented in the equation, if you want to have a complete cubic equation, it's going to be something like this: x cubed minus 2x squared plus 4x minus 7 equal to 0. Now this is a complete cubic equation. Complete. But here, if you look at this, this is incomplete. Because what term is missing? In the term in x is missing. So in this video we shall look at higher order equations, and this is part 1. Now there are several methods of solving higher order equations. It just depends on what equation. For this type of equations we shall do in this video, we shall solve it mainly by factoring. So with that said, it is highly recommended that you view the videos on factoring, all those videos on factoring. Factoring by GCF, factoring by grouping, factoring by difference of two squares, factoring by difference of two cubes, factoring by sum of two cubes, factoring quadratic trinomial, because the method of quadratic trinomial is what we shall use in some methods here. So it is recommended that you view those videos prior to doing this. As usual, with an equation, with equations we shall solve and check it. So let's get started. Question 1. P cubed minus 8p squared minus p plus 8 equal to 0. This is a complete cubic equation. So if we look at this now, we might decide to solve it using the rational root theorem. But before we try to do that, let's see whether we can factor by grouping first. Remember when we did factoring by grouping, it's 4 terms. So let's see whether we can do factoring by grouping first. Okay, so if we do that, we group in twos. This will be p cubed minus 8p squared. Let's group in twos, minus p plus 8 equal to 0. Or if you don't want to follow what I just did now, this is the horizontal method. In the video I did, I like using the vertical method. You can also do the vertical method. P cubed minus 8p squared minus p plus 8. So we now factor by GCF, just like the video that I did on factoring by grouping and also factoring by GCF. So the GCF here is p squared, you have p minus 8, and here you have a leading negative. When you have a leading negative, you factor out the negative first. So this is negative 1, p minus 8. Because negative p divided by negative 1 is p. Then plus 8 divided by negative 1 is negative 8. So what you have now from here is you have a p minus 8 times p squared minus 1 equal to 0. So this will be, you now use zero product property. Okay, please view the videos we did on quadratic equations. You now use zero product property. So this is p minus 8 equal to 0, or p squared minus 1 equal to 0. So this is p equal to 8, or here you can now this is an incomplete quadratic equation. And remember, with an incomplete quadratic equation, you check whether is it the second term that is missing or the third term. So please view the videos on incomplete quadratic equations. That is also recommended before you view this one. Incomplete quadratic equations, how do you solve them? So this is a case whereby you now do p squared is 1, so that p will be plus or minus square root of 1. Okay? And then p will be plus or minus 1. So what are our solutions? Our solutions is that P is equal to A, P is -1, P is 1. These are the solutions here. The solutions to the equation. What do we do next? We check. So we check this equation. We have P cubed minus 8P squared minus P plus 8 is 0. We have to check it for all of them. Left hand side, right hand side. Left hand side is P cubed minus 8P squared minus P plus 8. Right hand side is 0. So we can check for P equal to 8. P equal to 8, let's say 8 cubed minus 8 times 8 squared minus 8 plus 8. I can easily get it right away because this is like saying 8 cubed minus 8 cubed minus 8 plus 8. That will give you 0. 0, 0. So that works. Then you also check for P equal to -1. And if you do that, we can have -1 cubed minus 8 times -1 squared minus -1 plus 8. This is -1 minus 8 times 1 plus 1 plus 8. That is -1, -8 plus 1 plus 8. That gives you 0. Minus 1 plus 1 is 0, minus 8 plus 8 is 0. Then you also check for P equal to 1. So that will be 1 cubed minus 8 times 1 squared minus 1 plus 8. And that is 1 minus 8 minus 1 plus 8. That gives you 0, 2. So it works for the 3 of them. Do you understand it? Let's do question 2. Now question 1 is a complete cubic equation. It is a complete cubic equation. Let's do question 2. Question 2, 2m cubed equal to 72m. So here, what we want to do first, okay? Don't be tempted to say divide both sides by 2m or something. Don't be tempted to do that. The first thing you always want to do, when you have equations like this, always set it equal to 0. That's the first thing. You always want to set, if your equations are not set equal to 0, alright, you always want to set it equal to 0. Question 2 is not set equal to 0, and the question 8 is not set to be equal to 0. If the equation is not set to be equal to 0, in other words, if 0 is not the right hand side of the equation, you have to set it to be equal to 0. Okay? So you can write notes. Always set your equations to be equal to 0. If it is not set to be equal to 0, make sure you set it to be equal to 0 before you solve. Okay? In other words, make 0 to be on the right hand side. In other words, let 0 be on the right hand side. Okay? So if we have to set this to be equal to 0, what do we do? This will be 2m cubed minus 72m equal to 0. And then we can factor by what? We factor by GCF. We go ahead and factor by GCF. So that is why it's important. Those factoring, factor by GCF, factor by grouping, factor by difference of two squares, all those is important. So if we factor by GCF, what is the GCF? 2n, and you have what? n squared minus 36 equal to 0. So the next thing is you do your zero product property. You apply your zero product property. Okay, zero product property. That means that 2m is equal to 0 or m squared minus 36 is equal to 0. So if you do that, this means that m is equal to 0 because you divide both sides by 2. Or here is a situation whereby the second term is missing. So you can apply the square root property. You can apply the square root property, m squared equal to 36. So m will be plus or minus square root of 36, and m will be plus or minus 6. Or if you want from here, you can also say you can apply the difference of two squares. If you want from here, you can do that as well. You can say m plus 6 times m minus 6 equal to 0. And you also apply the zero product property, which means m plus 6 is 0, so m will be minus 6. Or m minus 6 is 0, m will now be 6. Whichever way you want to do it, that's fine. You can either use the square root property or you use the zero product property. It does not matter. So what we got now, folks, we have that m is 0, m is minus 6, and m is 6. So what do? We check. We check our work, and we have to check it with the 3 values. We have to check it with the 3 values. So we write check. Now when we check, we don't check with the modified equation. We check with the main equation. So we write the main equation, 2m cubed equal to 72m. Right? So we now write the left hand side, right hand side. Left hand side is 2m cubed. Right hand side is 72m. So we check for m equal to 0. If we do that, we have that 2 times 0 cubed. This is 0. Right? And this is 72 times 0. This is 0. So 0, 0. That works. 0 works. Then we check for m equal to negative 6. So we write 2 times negative 6 all cubed. And this will be 72 times negative 6. Negative 6 all cubed is 2 times 2, 16. 2 times 2, 1, negative 2, 16. Negative 2, 1, 6. 2 times 6 is 12. 2 carry 1, 2 times 1, 2 plus 1, 3. And then 2 times 2, 4. Negative 4, 32. Is what we have here. And then here, this will be negative. 6 times 2 is 12. 2 carry 1. 6 times 7, 42 plus 1, 43. Negative 432. So it works for negative 6. It works for negative 6. Right? And then we check for m equal to 6. M equal to 6. This is 2 times 6 cubed on the left hand side, and then 72 times 6 on the right hand side. This is 2 times 2, 16, which will give you what? 432. And this is 72 times 6, which is 432. It works. So that's your answers. Let's do question 3. Question 3, 5g4 minus 5g squared equal to 0. What kind of equation is this? This is a quartic equation. But it is what? It is an incomplete quartic equation. Incomplete quartic equation. So how do we solve this, and it is set to be equal to 0, so that's good. It's very good. It's set to be equal to 0. So how do we solve this? We factor by what? We factor by GCF. Okay, we factor by GCF. And when we do that, we have 5g squared. And what is remaining here? This is this is g squared, because 5g4 divided by 5g squared is g squared. 5 divided by 5 is 1. g4 divided by g squared is g squared. Minus 1 equal to 0. So we now see here we can use the zero product property. We can use the zero product property right away. We see that 5g squared is equal to 0, or g squared minus 1 is 0. So 5g squared is 0, so g is equal to 0. Okay? Or g squared is 1, and g will be plus or minus square root of 1. G will be plus or minus 1. Okay? G will be plus or minus 1. Now, later on when we do a rational root theorem, we shall look at the multiplicity of roots. When we do a rational root theorem, you know, with a quartic equation, you expect 4 roots. Okay, you expect 4 roots. But later on, we shall talk about this more when we do the rational root theorem next week. When we do that next week. Okay. Let's go ahead now and check this. This is a g equal to 0, g equal to 1, and negative 1, and g equal to 1. This is what we got. Yes. Right? That's what we got here. So, we now do what? Check our work. So we check, and when we check, of course, we check with the main equation. We have here 5g4 minus 5g squared equal to 0. Left hand side, right hand side. Left hand side is 5g4 minus 5g squared. Right hand side is 0. So we won't bother with the right hand side once we can make sure that the left hand side gives us 0. So let's check for g equal to 0. Let's check for g equal to 0. If we do that, we have 5 times 0, 4, minus 5 times 0 squared. This is 0 minus 0, that gives you 0. It works for g equal to 0. Then let's check for g equal to negative 1. Let's check for g equal to negative 1. We have that this is 5 times negative 1 all 4 minus 5 times negative 1 all squared. Right? So negative 1, you know, when we did the exponents, it's good you view the videos on exponents. When you have a negative base raised to even exponent, it's going to always give you a positive result. We talked about it. So negative 1 exponent 4, negative 1 times negative 1 times negative 1 times negative 1. It's going to give you 1. Now if you have a negative base raised to odd exponent, it gives you a negative result. Yeah, but when you have a negative base raised to even exponent, it will always give you a positive result. So this is 5 times 1 minus 5 times 1. Okay, I'll say 5 times 1 minus 5 times 1. And that gives you 5 minus 5, and that is 0. So g equal to negative 1 works. Then you do that for g equal to 1. G equal to 1, when you have that, what do you have? 5 times 1 raised to power 4 minus 5 times 1 raised to power 2. This is 5 minus 5, which is equal to 0. So g equal to 1 works. Okay? Alright, question 4. Next is what? Question 4. Question 4, you have 9g4 minus 37g squared plus 4 equal to 0. So this is the left hand side is a trinomial. Yeah, but this is still incomplete. It is an incomplete quartic equation. Incomplete quartic equation. What is missing? The cube is missing here. The cube is missing and the linear term is missing. Okay? G cube and G and G. The term G cube and the term G, they are missing. Now, if you look at this is what we have done. That is why I recommended that you view factoring quartic trinomials. Factoring quartic trinomials. Because this is a quartic trinomial. It's a quartic equation. But the left-hand side of the equation is a quartic trinomial. You do it the same way. Okay, so it's better you view that video, factoring quadratic and quartic trinomials. It is the same method that we will use. Same method. So here you multiply the first and third terms, right? So 9g4 times 4. That gives you 36g4. Okay? Now, we now look for factors. 36. 1 and 36 will not work, but -1, -36 will work. I say it right away. -1 and -36 will work. So this is 9g4 minus g squared minus 36g squared plus 4 equal to 0. Then I like doing my vertical method. So this is 9g4 minus g squared and then minus 36g squared plus 4. Okay? So this gives us what? What is the, you now factor by GCF. Factor by grouping, then by GCF. So this is g squared and you have 9g squared minus 1. And here you have what? -4 because you have a leading negative. When you have a leading negative, you factor out the negative first. We talked about that. When you have a leading negative, you factor out the negative first. So -4, you have 9g squared minus 1. So what do you have now? You have 9g squared minus 1 times g squared minus 4 equal to 0. Okay? So from here, what do you have, folks? You now do zero product property. You do zero product property. 9g squared minus 1 is 0, or g squared minus 4 is 0. Right? This will be 9g squared equal to 1. Okay, and then you do g squared is 1 over 9. And you have to do the square root property. So take the square root of both sides. This is plus minus square root of 1 over 9. So g is plus minus 1 over 3. Okay? Now here, g squared will be equal to 4. Take the square root property. That will be plus or minus square root of 4. G will be plus or minus 2. So what are the things you have now? What are the solutions? You have that g is -1 over 3. G is 1 over 3. G is -2. And G is 2. Next thing we do is to do what? Check our work. Let's check our work. Let us check our work. So I'm going to erase, so it will be easier for me to just check it from here. So I'll just write check here, check. And the left hand side, right hand side. Left hand side is 9g4 minus 37g squared plus 4. Right hand side is 0. So 0 is there. We won't bother with 0. Let's make sure that everything we get here will give us 0. We shall check it with the 4 solutions we have. Let's start with g equal to negative 1 over 3. So this is 9 times negative 1 over 3 all 4 minus 37 times negative 1 over 3 all squared plus 4. Okay, don't be scared of fractions, okay? Now, this is negative base to positive exponent. It's going to give me positive result anyway. So I can just say 9, this is 9 times 1 over 3 times 1 over 3 times 1 over 3 times 1 over 3. Because negative times negative times negative times negative is positive. Positive times negative is negative. Negative times negative is positive. But some people might still be confused. So let me just put the negative. But I'm not going to join it to the negative will cancel out. Because when you multiply 2 negatives, it gives you a positive. Then minus 37 times 1 over 9. I can just go ahead and put 1 over 9. Then plus 4. So folks, see what I have to do here. 3 times 3 is 9. Bam, bam. That is gone. Okay, 3 times 3 is 9. So that is gone for that one. So what do I have here now? What do I have from here? What I have is 1 over 9 minus 37 over 9 plus 4. And that would be 1 over 9 minus 37 over 9 plus what? 36 over 9. Because 4 is 36 over 9. Okay, LCD is 9. What is the equivalent fraction with 9 as the denominator of 4 over 1? 4 over 1 is 36 over 9. So this will be negative 1 minus 37 plus 36 over 9. And that is negative 36 plus 36 over 9. 0 over 9, which is 0. So it works. And the same thing applies to g equal to 1 over 3. If it's g equal to 1 over 3, you will still get that because this applies to the same thing. You have 9 times 1 over 3 times 1 over 3 times 1 over 3 times 1 over 3 minus 37 times 1 over 3 all squared, okay? Then plus 4. So it's the same thing, okay? Plus 4. It's the same thing. It will give us 0. The only thing is that with this one, the negative times negative, positive times negative, negative times negative, positive. Yeah. But with the positive, it's gonna give us the same thing. Okay? If you substitute it and do it, it gives you the same thing. The same thing will come to 2 and negative 2 because this is 4 and squared, g4 and g squared. If we do g equal to negative 2, okay, all you need to do is to substitute it, but it's gonna give you the same 0. If you do g equal to negative 2, you have 9 times negative 2 all raised to power 4 minus 37 times negative 2 all squared plus 4. Right? So that will give us 9 times what? 8. I'm sorry, 16. What is wrong with me? 9 times 16. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. Negative 8 times negative 2 is 16. Then minus 37 times 4. Then plus 4. 9 times 6 is what? 54. 4 carry 5. 9 times 1, 9 plus 5, 14. Minus 7 times 4 is 28. 8 carry 2. I'm sorry, 4 times 7, 28. I should do it 4 times 7. 28. 8 carry 2. 4 times 3, 12. Plus 2, 14. Then plus 4. 144 minus 148 is what? Minus 4. Minus 4 plus 4 gives you 0. It works. This one works. 0. Then if you also do g equal to 2, you still do the same thing. 9 raised times 2 raised to power 4 minus 37 times 2 squared plus 4. This is going to give you 0. It will still give you 0 because it will be 9 times 16. This stems from the fact that negative 2 all raised to power 4 is the same as 2 4. It's the same thing. When you have, please view the videos on exponents. When you have a negative base raised to even exponent, okay, raised to even exponent, then it gives you a positive number because negative 2 exponent 4 is 16, 2 exponent 4 is also 16, so that's why, 16 is 16, so you could literally say that, if you have it with even exponent, raised to power 2, raised to power 4, raised to power 6, raised to power 8, raised to power 10, and the rest of them. Then please, we shall do the next video so that this video is not so long. Next video we shall continue from 5, raised to 5, 8, and we shall start with 2. Okay? Have any questions?